All right. Good morning, February 24th, 2025. Lecture on our telephone systems today, and today we will, there we go. Today we will talk about telephone systems, and this is part of two series, or series of two. We're going to talk today about the conventional telephone systems, and the next class scheduled for this week, the other hour, we're going to talk about the VoIP telephone systems. Excuse me. So let's just start on this. What we have on the screen here, we have something that's called a phone system. What's a phone system? Okay, a phone system is a device that routes all the incoming and outgoing telephone calls, and you can use that to dial internally, to call people internally. So, as far as a conventional telephone system, it is a box. It's a physical box. I keep saying box a lot because it's a thing to say. It's a box that contains all the electronics and all the connections to connect telephone sets that are sitting on people's desks or mounted on the walls or whatnot. It also is connected to some other. It can be connected to other peripherals, such as device that is called music on hold, and we will talk about that a little bit because it used to be just like a radio playing. So if you put someone on hold, they're listening to the radio or something like that, right? Now there are some more sophisticated, more complex solutions to that. Some companies were clever enough, some people were clever enough to actually make business out of that, and we will touch on that as well. It also, the phone system can be interfaced with peripherals such loud ringers, which means it's a loud bell that rings if you want to hear the phone ringing over the large noisy area like a production hall. There could be a loud ringer above the supervisor's office door. So if their phone rings in their office, they won't hear it. But if there's a loud ringer above their door, and maybe sometimes connected with a strobe light, then they will know that their phone rings in their office, so they can go and answer that, right? Also, truck drivers' gates. There would be devices that, with the press of a button, you can connect to whatever telephone set. You will program that. Other things, PA systems, public address systems. That PA system that we have, we have installed on our wall. Consisting of a bunch of 70-volt speaker stations connected to an amplifier that can be also interfaced with the phone system, so you can do pages, all call page or zone page, using a telephone set. So for the most part, there are different brands. No, I didn't want to do that yet. This is what I wanted. For the most part, you will have something like it could be a small telephone system, and there are different brands. This one is sort of discontinued, North Star Meridian, but because it can pretty much recognize these telephone sets, very popular phone sets, like all through the 90s, 2000s, and still, because those phones were so good, somehow, even though Northern Telecom is not producing those anymore, the business is out, you can still find either refurbished phone systems by that name, and I'm not sure if somebody's producing brand new ones somewhere offshore. Don't know. But I find it a little bit strange sometimes that you can, if you want to have some replacement parts, you can still get some devices that look like they were brand new, right? Because they were so good. Now, there are different ones. Panasonic is a popular one, Toshiba, and there are some other sort of less known brands to the public, okay? VoIP telephone systems, which we're going to be talking about during the next class, is taking over quite heavily, and there are some reasons. We'll talk about those. Right. So there could be a small system. This one is 3 by 8. What does that mean? This one here can take three three incoming telephone lines from outside, and you have a capability of connecting 8 telephone sets. Distributed by on people's desktops and whatnot. A quite popular solution for a small business. Then there's a bigger one here. It's 616. By the logic of what I just said, this one, the 616 phone system, can accommodate 6 incoming telephone pods, lines. And you can have 16 telephone sets distributed around the business, around the facility. So these are the small ones. Then you get into something that's called that would be like modular. So you can add on modules. So here will be the main KSU, and here's terminology. I'm introducing to you. KSU stands for Key Service Unit. Or sometimes it's referred to as PBX, which stands for Private Branch Exchange, as opposed to like local branch exchange. It would be some kind of a building somewhere on some street in the city that would service the whole telephone distribution, telephone lines distribution over some area. So it would be local branch exchange. But this one would be private branch exchange, which would be basically a phone system installed in the facility. It could be a shoe store, it could be a travel agency, it could be an office building, it could be a big plant, like a factory. Right? Now, if you want to, or it could be a hospital or a school. So if you want to get some like more telephone sets, you're talking like maybe 200 telephone sets or something like that. Then you want to get to some sort of like a modular solution, so you can add on the modules to accommodate either you need more telephone sets, or do you need more telephone lines, and usually that would be something like that, right? Or do you want a voicemail? There would be modules like that, so you can just keep adding. Now, what else do we see on this first opening picture? Something very familiar. BICS is associated quite heavily with phone systems. And this week, no, this is the class of 2025 winter. So if you're watching the video later on, please ignore the dates that I'm, obviously, that I'm saying. So we have done already the lab connecting 25 pair cable onto a BICS termination strip. But the next lab, because this week we have an open lab, so if you have any outstanding work, please just join any section. All right. We're going to also next week, we're going to have a lab that is called is it next week or is it the week after that? We call that POTS lab. We're going to, in some sort of a miniature way, simulate telephone connections. But we'll cross that bridge when we get to it. All right. Now, okay, let's go here. I'm going to leave this slide as the last slide because I might go a little bit over time today. So as always, if you need to go to another class, please log off and go to another class, and you can catch this, catch the last couple minutes. on YouTube when I publish that, and usually I publish that within about half an hour of the class ending. Because there's a lot to talk about here, right? I'm just going to mention a couple of those. CO line. CO stands for Central Office, so therefore CO line is a telephone line. It's a POTS line, also sometimes referred as SL, single line. Right? CO line or SL line, same thing. All right. We'll talk about the other ones. I just want to go in some details, but I'm afraid that if I stop on this slide and go over all that terminology, we won't have time to do the other stuff. So I'll leave this thing for the last. All right. Now, BICS connections. Remember that 25 pair. Here is a BICS frame. Here's another BICS frame. Here's some wire management equipment happening here. That is medium-sized facility, small to medium-sized facility. Those things fill up pretty fast. So you have a bunch of 25 pairs connected, coming from somewhere. And over here you can see that there's more 25 pair cables going somewhere else. And those are terminated on this BICS field. These are terminated on this BICS field. And of course you have cross-connect wire that you can basically connect that pair to, using cross-connect wire to whatever pair you need to be connected. Maybe those are going to something that's called secondary demarcation point or so on. Excuse me. All right, sip of coffee. I talk a lot. In a nutshell, that's, sometimes things are a little bit more complex, but you learn as you do that. Here is a typical BICS frame, which we already have done right? We already have done already. Yeah, there we go. Okay, so we have, we terminate the 25 pair, for example, on the front, then we flip it around, and so we can grab those pairs for cross-connecting. Also, you get things that are called M-phenol connectors or RJ21X, and the X stands for male or female, right? And you have tip and ring. Look at that, tip and ring, tip and ring. The connector looks like this. Right? So here's 25 pair cable, and the 25 pair cable is terminated on this type of a connector. All right, and here is how things are being done. Look, there's white, blue, white, orange, green, white. So 25 pair. This is how things are being connected. Now, the tool that is used to terminate the 25 pair cables on the RJ21 connectors, it is called a butterfly tool. All right, this is what the connector looks like, and this is what a butterfly tool looks like. All right, basically you insert that. First you distribute the wires on the left and on the right, depending on the male or female configuration that you have. And then you insert right here the connector, and you close those handles, because normally those handles are open here. All right, gotta sneeze. Excuse me. And then you just close the handles. That's why it's called a butterfly tool, because maybe it looks like wings of a butterfly. It used to be expensive tool, costing $600 to $800, sometime around 90s. Not because it is so expensive to make, but because they could charge for it. That's usually how it works. Now we can find that butterfly tool maybe for $80 on eBay or something like that. So not a big deal to buy that. And here is when you download this presentation, which is triggered to be released on Friday, then you can click on this, or you can just type it when you watch the video. There's a little short kind of a video demonstrating on how things are being done when it comes to terminating the 25 pair on the M-phenol connectors. Also, in some telecommunications distribution stores, you can buy pre-made cables. So you can order, I want 5 females, 25 feet long, 50 feet long, 6 feet long. All right. So you terminate, basically this gets plugged in. Let's see here. Can I see it somewhere? You see here? Those plug in here into those modules just to save space. You just plug them in, and the other side fanning out, and you can terminate those on the BICS frame. Pretty nice and slick system, I would say. Let's see, where were we? We were here. Okay. Now, so next slide here. This is a typical small 3x8 telephone system that can accommodate 3 incoming telephone lines, and you can see that here, those 1, 2, and 3. And now, some of the systems will have those telephone jacks or RJ11 or RJ12 jacks just embedded physically onto the chassis, so you can plug in the phone lines using telephone cords. Okay. Now, some of the phone systems will have another connector like that you can plug in, and then you basically fan out and terminate the 25 pair on the BICS frame, so you can grab the pairs. So you can grab line 1, line 2, and so on. This one here is like this, right? Just the 3 telephone lines, and here is the RJ21 connector that fans out onto the BICS frame, and from there you're going to have to use the installation manual to basically know which pair is what. And usually on this one here there will be first 8, because this is 3x8, right? So it will be the first pair would be, because these extensions, they just use one pair for this particular phone system. Some of them use 2 pairs, but this phone system uses 1 pair per phone set. So the first pair will be extension 1, or the second one will be the second extension. So you get 8 phones you can just plug in here, and there's a bunch of nothing, like no man's land. And maybe the last one is going to be an input for music on hold, so you could basically get the 1/8" plug. It looks like a 1/4" plug, but the headphone plug. All right, plug it into the headphone output of the radio, and you punch those wires here, and the music on hold, well, has to be programmed, like enabled by a system, because you can when you put somebody on hold, you can get those beeps that sound like beep beep. You know how they sound, or sometimes just a silence, or you can have music on hold, like. So you're enabling this source, and there's some other peripheral connections here, maybe an output for paging and things like that. Just have to look at the manual, and we do have one of the slides here. We have an example of that. All right. Now, tip and ring. We already talked about that. Remember, just as a reminder, the early telephone exchange looked like this, and the operators would use those patch cords that were 1/4" plugs, and the 1/4" plugs would have tip and a ring. Sometimes you will have tip, ring, and sleeve. That's where it comes from. We already have talked about that. Remember, tip is more positive than the ring. See here? Tip is more positive than the ring. However, the tip and the ring, it's not like telephone ringing. It's the ring here. Here's a tip and here's a ring. Here's a tip, ring, and sleeve, depending on whether you want to use balanced or unbalanced signal. Usually for audio, but for telephones, it will be a tip and ring. And just remember, tip is more positive than the ring, but the tip sits at the ground level. Now, this one says about, we're talking peripheral devices on this slide. While designing a system which involves interfacing an ATA or other peripheral devices, such as a paging interface or loud ring, confirm the specifications. Okay, we're gonna talk about that in a sec here. All right. Here is, go back to a slide here. I'm shuffling between slides. All right, so for example, the phone system can be solved like this. The first 8 could be, or the first whatever number of pairs would be the extensions. And in this case, with the first 8, because this is 3 by 8. Then you have music on hold, which is an input. Then you would have something else, maybe whatever. It's going to be the audio out for paging. So if you want to do an all-call page, you pick up the phone, you pick up the headset, you dial the button or the feature number for outgoing audio page, and you wait for the confirmation tone by the system, and then you can speak. Right? Fire, everybody get out. Or this is not a fire, this is just a drill. Something like that, right? So you can connect that output, one of those pairs, whichever it is, okay? You can connect that straight to an amplifier. Also, there's going to be another, usually in the telephone systems, there's going to be a relay closure or relay contact. If you don't know what relay is, research that, or next time we're in person, ask me to explain what a relay is, okay? Basically, it's a dry contact that is not connected to anything. It's like a light switch or a switch that is enabled by electromagnet, okay? So it's an automatic switch. You don't use a finger to press the switch. The switch is being pressed, presses itself if there's certain power applied to certain terminals of the relay, okay? Now, the relay is a dry contact and usually follows by the page. Why do we have that? Now, just if you think about that, do we have an amplifier? No. All right, let me, there we go. I got my board here. There we go. All right, let's say there is a phone system, which is basically can be represented as a box. Here's a phone system. All right, bunch of lines coming in, and a bunch of telephone sets connected to it, right? And then we have an amplifier, audio amplifier, connected to a bunch of hallway speakers. Remember that? All right, here's hallway speaker, here's hallway speaker, here's hallway speaker, okay? And from the output, by one of the outputs on BICS, the output of that is going to be connected to an input of the amplifier. No problem. Pick up the handset here, press the page button, and the magic happens in the box, and your handset is connected to the microphone of your handset is connected to the amplifier. You speak and you hang up. What's happening here? This amplifier has to be on all the time. So this input here is going to pick up all kinds of noise that's in the air, some interference and whatnot. And during the time that the pages are not made, which is most of the time, you're going to hear some kind of a hiss or noise in the speakers. Very annoying. It just not very practical, not a very good thing. Right? So what happens is that the commercial amplifiers will have an like input enable contact here, right? And that is also going to be connected to the dry contact relay here. So when the page is being made, you pick up the handset, press the page button, two things will happen. The audio output is going to be enabled, connected to your microphone on a handset, plus this relay is going to click and it's going to turn the input on. It's going to enable the input. When the page is done, your audio output of this box of the telephone system is disconnected from your handset. It's just ready to be used by anybody else. And the relay either opens or closes depending on the specifications of the paging amplifier. Basically, the relay is going to disable this input, so there is no background interference noise transmitted as some form of a hiss through the speakers. Okay? Right. Now, okay, I did it prematurely here. So this is in a small type of environment. Well, what if you have more than one zone? What do I mean by that? Let's say this will be the hallways. Halls, okay? Now, there's going to be another amplifier that is connected to the speakers, all right? And there'll be offices. There could be another amplifier that is connected to the production hall, and so on. There are a couple ways of solving that. You can actually do it with one amplifier only. But let's just, for the simplicity of things, to understand the concept, we're going to have amplifier channel for each type of a scenario. Well, if there's a huge operation like a big factory or something like that, and the shipping and receiving department is receiving a lot of pages. There's a track on gate number 5, or there's this, that, can you just go and load this, blah, 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 right? So there could be the pages, the audio page traffic could be intense in that area. Well, the office people don't need to hear all that. Some of the other departments, accounting or so, they don't want to hear that. They don't need to hear that. Okay, so the page could be the paging system could be divided into zones. So you can transmit the audio page to just the hallways, just the production plant, maybe just the some other department, accounting or whatnot. Okay. And those zones could be numbered, depending on how the installation took place. Well, and let's say you only have one audio output. Well, we can do something else here. We could have, let me just get my eraser. Here it is. All right, I'm going to erase all those amplifiers. And I'm going to draw one amplifier. Maybe here. And the output of the phone system is going to be connected to the input of the amplifier. All right. And we can have connections going to different zones. Did we solve the problem? Well, not yet. We need to have some sort of a switching device that is going to turn on the specific zones that we want to page. Okay, so let's erase that here for now. And put another device here. Right here. Now, that device has one input and it has multiple outputs. And we call it a paging interface, PI. Now, the paging interface is also connected to the phone system. However it is connected, it usually acts as a phone. So the phone system thinks it is connected to one of the telephone sets. Let me just erase the unnecessary pollution here. All right, and then when you want to do the page, the audio page, you will dial the extension, because a phone has an extension like 237, 238, 239 or whatnot. This could have 257 for this particular facility. And it is going to pick up. And it is going to be programmed to respond to the ringing signal. And it is going to give you a confirmation tone so you can do the page. Or it's going to give you the confirmation tone before you speak right away. It's going to ask you to press a zone. So people have to be trained on how their phone system works. So in some cases, there's a beep and you can talk right away. In some cases, there's a beep and that you need to press zone 1, zone 2, zone 3, or whatever number, or 0 for all call, okay? And then you can speak. So this paging interface is going to, based on your input from your keypad here on the telephone, it is going to connect you to either hallways or the offices or the production hall or whatever the setup is. Now, here's another sort of a hurdle that we need to overcome. Because, let me just, here. Here's what the paging interface looks like. This is by Bogan, very popular company here. Now, when it comes to the phone system, these phones, they do not accept the POTS signal. They do not accept the regular telephone line signal. They are made to understand the signal protocol that comes from this box. So Panasonic will have their own protocol. Toshiba will have their own protocol. Some other companies that they make, they'll have their own type of a signal, and those phones are called proprietary telephones. They are not. If you plug them in, if you plug one of those phones into the regular telephone POTS line, that phone will not understand that signal. Okay, well, so here is the big fanning out here for all the extensions. And here's the problem. Where are we? Yeah. This paging interface is a universal paging interface. So it's not made for Panasonic. It's not made for Toshiba. It's not made for Northern Meridian. It's not made for any whatever other company. It wants to see POTS signal. It wants to see the POTS ringing voltage in order to respond. But the problem is that these phones do not produce POTS ringing signal. They have whatever signal they do. Well, so we do have a problem here, right? Well, we have a problem, we have a solution. We have something that is called ATA, and it's called Analog Telephone Adapter. Now, those are made by the same company that produces the phone system. So Northstar Meridian was going to have their own ATA adapters. Panasonic is going to have their own ATA adapters, and so on. The idea is that it will have two connections. One connection is going to be for you to connect the ATA adapter to the phone system, so it acts like a telephone. All the guts, all the electronics are kind of tricking the phone system to think that you have a telephone connected to it. And there's another connection on the ATA adapter that is basically a POTS jack. So it converts, ATA converts the signal protocol that is understood by the phone system into a single line POTS, kind of a phone line. Now that is going to be connected to the universal paging interface, and now we can communicate. So what we have here, where's my here, that paging interface is going to be connected through another box that is the analog telephone adapter. So here is the proprietary signal coming in, and over here is POTS. Paging interface understands POTS, receives the ringing signal, responds, and you can either press the number of the zone you want to page, or you can just talk right away, depending on how the setup is done. Now, if anybody has, well, like a landline, but it's called telephone over internet. And the company that your internet provider is going to give you the modem to connect to your, the internet and your PC and whatnot. Excuse me. And they're going to give you something that's called a phone box or telephone box. Well, that telephone box is also an ATA. It's an analog telephone adapter. If I zoom here, I wonder if I could see that here. Oh, look, it just says ATA. But they call it a phone box because they just don't want to explain to everybody that's what ATA is. Okay? But it is an ATA. It understands the signal coming from your modem, and it transfers that into a POTS jack, POTS line. Here's another peripheral device. It's a loud ringer. Loud ringers are quite popular in the industrial environment where there's lots of noise, production line noise, and so on. So this can be mounted on top of the supervisor's office, and this one would be producing a huge, loud ring, and maybe a strobe light flashing. Some noisy environment, like for example, where there's in some of the plants where they do PVC or plastic productions, they have something that's called mixing towers, and this is the mixing tower is where people throw in all the chemicals and all the powders that in right proportions in order to make PVC pipes or so on. And there's a telephone there, but that mixing tower up there is noisy. So if somebody wants to reach that, somebody who's in the mixing tower, they will have phone there, and they will have the loud ringer installed not too far from the phone or somewhere there, just to let them know that that the phone rings. Normally they wouldn't hear the phone, right? Now, here's a $64 question or explanation or answer. While designing a system which involves interfacing ATA and other peripheral devices, such as a paging interface or a loud ringer, confirm the specifications of all devices involved. Different devices can be made by different brands, bearing different input-output levels. Best thing, read the specs and confirm in practice. This can save you a lot of time and aggravation, especially while designing a larger system involving purchasing and installing multiple devices. A mouthful, all right? This is here about, well, there's a reason why I put this thing here. I had a situation that we were retrofitting a huge plant, huge factory, with the VoIP system. So we were getting rid of the regular phones, and we were giving them the VoIP telephone system. We were to keep the existing paging system, which means we just had to, and when the paging interface, we just had to install different ATA adapter because we had the Cisco VoIP telephone system there. So we needed a Cisco ATA adapter, Now, how it was done, it was, there's a big company somewhere in Montreal, or somewhere in Quebec. I think they're in Montreal. And they would do the sale, and they would call us to do the installation. But all the phones were programmed. Everything was. We just had to distribute that the phones, make some connections, and do the interfacing with the audio. So there was a bit of a setup involved on our part as well. And everything was working fine except for the paging. The paging interface was not responding. So, what do? Check the wiring, okay? Check the wiring again. Make sure you have checked the wiring properly and check it again and again, and it seems like everything is fine. Call the brand here that made the, call the tech support here. Confirm, everything's fine. Call the brand here. Confirm, everything is fine. But it doesn't work. And to make it even more funny, or not really funny, but funny in a wrong way, is that the company who sold the VoIP system, they had a mock setup involving real equipment on their floor. So things were connected physically, for the purpose of troubleshooting and tech support. They confirmed everything on their side. It works. When I'm installing that thing, it doesn't work. That was one of the most difficult troubleshooting things. And but now I'm giving you the experience here. Big shout out to Mr. Barry Windsor for Windsor Telecommunications. I think Windsor Telephone, Windsor Phone. We call in the big guns. Yes, I do have a lot of experience in this business, but there are people who have even more experience than I do. Mr. Barry Windsor, find out what the problem was. The problem was that the revision, the model number was all fine, so everything was good. The revision number, later on the company has released another version of the same equipment. So it was the same model number, revision 2.1 from year so-and-so. It should work. But no, because the original one, the earlier version, had enough voltage and enough current capability to power up this input of this the input jack of the paging interface. The new one had just minimal specifications, and it was just below the threshold of what this wants to see. That's why. Here's the big thing here. So sometimes things look like they should work, but they don't. All right. Now, this is, we're coming up to 10:02. So you know what? I'm going to stop here. We're going to continue within the next class. we're going to continue from this moment on during our next time that we meet each other. All right, because there's so many things here that I want you to know. I don't want to skip any steps because later on you will be the ones who will leave the school and you will be in the field trying to either install things or troubleshoot things. I want to give you the best that I can possibly give you, so I don't want to skip any steps. All right, so we're going to stop here, and I'm going to welcome back after the break, and please have a wonderful rest of the week. Bye for now.